Okay, boys and girls, just so that you're in good shape for your holidays and you've got that assignment that's coming up, let's just take a moment and talk about ionic equations and about some solubility rules. You'll need that to be able to finish, I believe, pages 9 and 10 of the homework package that I gave you. So, I'm going to give a few examples here. So, use let's try to do something that's not, I have an example that's not an acid. Okay, why don't I use sodium, example of sodium phosphate, that's PO4, so that's 3, that's 2. It's in solution, so it's aqueous, very important. We need to have the state of matter here. Plus calcium chloride, aqueous, goes to make, so a lot of these are double replacement reactions, so that's going to make salt, NaCl, and calcium phosphate, PO4 phosphates have a 3 minus, that's 3, that's going to be 2. Okay, so the reason why I didn't put the state here is because we need to think about our solubility rules and see if we're going to have a precipitate, a solid that's going to form. And then that doesn't need to be part of our ionic equation. So we know that group 1, the alkali metals with the halides, they are all soluble, so that will be aqueous, it's soluble. Phosphates, if you look at the solubility rules that I've given you, are not soluble unless they're with, I believe, group 1 metals. But calcium is a group 2, it's an alkaline earth metal, so it doesn't work. This will be a solid precipitate that would form for this, so it's got an S. Okay. The next thing we need to do is balance this out. So let's see. It's going to be a little bit tricky because I've got 3 here, but I've got 2. Why don't we try? I'm going to try 6. So that means I need, if I have 2, CO2, maybe 3, and then that should work, right? No, see, that's my mistake there. I was wondering why that wouldn't work. That's got to be like this. Okay, good. Because sodium's got a charge of +1, Mr. Harrison, so it doesn't have a charge of +2. So now that makes it work. I was wondering why that the phosphates weren't going to balance. Okay, so that's all balanced out. So that's our molecular. This is these pens are ridiculous. Molecular equation. Okay, this is just a common thing we've been doing all along. The only new thing about doing these molecular equations is you need to think of state of matter, and we need to look at our solubility rules and see if we're going to have any solid precipitate form. They're the ones that are going to be, this is insoluble in water, so once this reacts and undergoes a double replacement reaction, we're going to make something that is no longer soluble in water, and it will come out of the solution. Okay, so that's what we need to do. So unfortunately, you're going to have to memorize those solubility rules. So that's the molecular equation. The next thing we need to be able to do is write a complete ionic equation. So that's with all the ions. So we're going to break it apart. So this means Na3, what does that mean? So that means I've got 3 times 2, so that's 6. I've got 6 sodium ions, that's aqueous, and plus 2 PO4, we need the charge 3 negative aqueous, plus 3 calciums 2 plus aqueous, plus 2C, no, that's not 2, that's 6Cl minus aqueous, makes 6Na, that's right, because now that balances out, plus aqueous plus 6Cl minus aqueous plus, and then the next one, the calcium phosphate is all together because it's a solid, it doesn't break apart into ions. So that's your complete ionic equation. Okay. The next part you need to do is you need to, you're going to write what's called your net ionic equation. And to do that, you just cancel out the spectator ions, right? Remember, the spectator ions are the same ions that are on both sides of the equation that don't do anything, right? They're not involved in making this. If they're not involved in making this, then they're not actually doing anything. They're just there in solution watching the reaction. That's why they're called a spectator. Spectator is somebody who watches, say, a soccer game, a football game, a baseball game, hockey game. Okay, so we can see that NA's here, NA's here. It's not doing anything, it cancels out. PO4 is here, but PO4 is involved in this, so it's not a spectator. Calcium's involved here, so it's not a spectator. Chlorine, this is a spectator, it's not involved. So, what do we write then? For an ionic equation, we write 2 PO4, 2 phosphate ions, aqueous, plus 3 Ca2 plus aqueous, gives us Ca3PO4 solid. Okay? That's what we do there. Do I have time to run through one more example? I wish I had examples. Let's do one more. Let's do sodium hydroxide. It's a strong base. Okay, you don't need to know about acids and bases for this course, but I'll tell you what it is. Sodium hydroxide is a strong base, and what does that mean? It means it breaks apart, it disassociates completely in solution. It's a strong electrolyte. Plus copper sulfate, and sulfate's got a charge of 2 minus, so this has to be copper 2 sulfate. Gives us sodium sulfate plus copper 2 hydroxide. Okay. Sulfates are, if you look at your solubility rules, sulfates are generally soluble. There are a few exceptions, but we know that for the most case with alkali group 1 metals, most things are soluble. So this is fine. This will be aqueous, it's soluble, it'll split apart. Hydroxides are for the most part insoluble, meaning they don't dissolve, except if they're mixed with group 1 metals, right? So we've got our first case over here, sodium hydroxide. Sodium's a group 1 metal, so it dissociates nicely. Copper is not a group 1 metal, so this will form a solid precipitate in the bottom. Okay. So this is our molecular equation. The only thing else we need to do for a molecular equation is make sure that it's balanced. So 2 sodiums, 1 hydroxide. Oh, so now I've got 2 hydroxides, I've got 2 hydroxides, I've got 1 copper, I've got 1 copper, I've got 1 sulfate, I've got 1 sulfate. So that's perfectly balanced. Okay, so our next step, complete ionic equation. So we're just going to break it apart into all the different ions. So this would mean I've got 2 sodium aqueous plus 2 hydroxide aqueous plus copper. Now careful, we need to get the charge on this correct, right? So sulfate is always -2, so that means since there's only 1 here, then that's got to be a +2. So it's got to be copper 2 sulfate. That's going to be 2 plus aqueous plus SO4 2 minus aqueous. And good day. On the other side of the equation, we have 2 sodium plus aqueous. And then this is solid, it's the precipitate, so we just write it as it is. Copper hydroxide solid. Okay, net ionic equation. We need to cancel out all the spectator ions, the ones that are not involved in making this. So, sodium is on both sides, it's not involved, so we're going to cancel that out. Hydroxide is involved, we're going to leave hydroxide, so I'm going to write it down, 2OH aqueous plus. Copper is involved in making this one over here, so copper 2 plus. Aqueous. Where'd my sulfate go? Oh, I didn't write my sulfate on the other side. Aqueous. Okay, so sulfate should cancel out as well, and that will give us copper hydroxide solid. Okay, you should be able to check too at the end as well. You should have, it should be balanced at the end. You shouldn't need to do anything. If it's not, then you're gonna have to go up. Either you did something wrong by expanding it incorrectly in your complete ionic equation, or it was not balanced correctly in the molecular equation. So here we see we have 2 hydroxides. Over here we have 2 hydroxides. We have 1 copper, we have 1 copper, so that is balanced correctly. If the question asks you, it could ask you to list the spectator ions. Again, those are the ones that are not involved in making the precipitate or sometimes the gas or the liquid. So in this case, it'd be the ones that we took off from both sides. That would be sodium would be a spectator ion here, and the sulfate ion as well would be the spectator ion. Okay, the big trick to this is, I think you can do all of this. This is not very hard. The only trick is we need to learn the solubility rules. So you need to go to your solubility chart that I've given you, consult it, try to memorize it. Okay, if any questions, let me know.